Oh. Do 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 do. I was wondering why this is, it's because I have the show collision flag on. Okay. Oh, I got a slight stomach ache. I might make myself some coffee here in a moment. Holy cow, the stomach ache needs to go away. Let's see here. Let's change this view to one viewport. And let's go with that's fine. What I'm actually wanting to do, so what I was actually working on before was some custom navigation, but I don't think that I actually need any custom navigation. I think what actually exists in the engine is completely fine. I was going to use originally Limbo AI, but I didn't. It's not that. This is more of a learning adventure it's a learning adventure and kind of a product building thing. So I mean, using plugins will speed things along, but I think I could do things pretty decent on my own. I mean, Godot makes things really easy to modify and whatnot, but I do want to try my hand at something at least. Excuse me. Let's see here. So I did create us some characters. Well, it looks like the bat did not make it. Oh, no, I haven't created the bat yet. We do have kind of a small little rat scene here. Just kind of a little stand-in for what I'm thinking. A rat. Maybe get some simple AI on this, perhaps. See here on the rat. I think I could go to add a child node. Like, I'm not entirely sure how to do navigation. Like, we have a navigation region. Let's go ahead. We have a traversable region that navigation agent 3Ds can use for pathfinding. I want to know about navigation agents. 3D agent used to pathfind to position while avoiding obstacles. A 3D agent used to pathfind to position while avoiding static and dynamic obstacles. The calculation can be used by the parent node to dynamically move it along the path. Requires navigation data to work correctly, which I think we have with the navigation area and the navigation mesh. Dynamic obstacles are avoided using RVO collision avoidance. Avoidance is computed before physics, so the path finding information can be used safe in a fixed step. After setting the target position property, the get next path position method must be used once every physics frame. Okay. Note, several methods of this class, such as get next path position, can trigger a new path calculation. Calling these in your callback to an agent signal, such as waypoint reach, can cause infinite recursion. It is recommended to call these methods in the physics step, or alternatively delay their call until the end of the frame. Call deferred, or object.connect deferred. Okay. So this here is the navigation agent. So I think if I go to the rat scene, let's go to 3D, not that I need to. Add a child node, add a navigation agent, and I didn't see, or at least I didn't pay attention. Oh, they keep these under. Okay. This inherits object, which is basically a node. Or it inherits node. Either way, because of that, pathfinding, avoidance, process physics. Okay, so this here is our navigation agent. So how use? Method descriptions. Okay, so it's an experimental class. Open in online docs. See here. Navigation. Oh wait, hold up. Navigation agent 3D. Here we go. Tutorials. Using navigation agents. Here we go. Navigation agents are helper nodes that combine functionality for path finding. See here, path following and agent avoidance. See here, new navigation agent nodes will automatically join the default navigation map on the World 2D and World 3D. Navigation agent nodes are optional and not hard required to use navigation system. Their entire functionality can be replaced with scripts and direct calls to the navigation server API. Oh, okay. For more advanced uses, consider using navigation path query objects over navigation agent nodes. Okay. See here, navigation agents query a new navigation path on their current navigation map when their target position is set with a global position. The result of the path finding can be influenced with the following properties. The navigation layer bitmask, all of this stuff. See, disabling path metaflags with disabling related signal emissions. Target agent path following. See here, after target position has been set for the agent, the next position to follow in the path can be retrieved with the get next path position function. Okay. Once the path position is received, move the parent actor node of the agent toward this path position with your own movement code. The navigation system never moves the parent node of a navigation agent. The navigation system never moves the parent node of a navigation agent. The movement is entirely in the hands of users and their custom scripts. Okay, that's good to know. So I just need to set the, see here, get next path. So I need to set the path, get the next path in its physics process. Okay. Okay, here we go. This is helpful. User contribute. Which Godot version are you using? Oh. Okay, here we go. So, we are missing, we're not missing really any important criteria. I mean, we kind of are. Characters, rat, seeing GD script. Here we go. We have physics process. We have, if it's not on the floor, then the velocity equals gravity plus delta. That is correct. Handle input. This is the default template. We're obviously not going to have, I don't think we're going to have a jump for the rat. We might. In the meantime, we don't. And then input direction. This we want. But this isn't going to be the input direction. And then we have speed and jump velocity. Okay. This is good. So let's go ahead and bump our navigation agent 3D there. We will add a at on ready there. Nav agent yeah. Nav agent, and this will be the navigation agent 3D equals, I think it's oh, this hasn't been saved yet. So if we save this and then we come back to this here, we could hit $ navigation agent 3D. Oh, is this supposed to be, I'm sorry, I think this is supposed to be this, and then this, and then that. On ready, my bad. And then the $ actually goes here. There we go. So that gives us our navigation agent. Our navigation agent is in here. This here we have kind of all of our information about our target. We go to 3D. We can say our collision shape is a radius of 0.05 meters. Avoidance. Here we go. 0.05. 0.05. I don't know if that's helpful. Use 3D avoidance, keep Y velocity. That's interesting that it says keep Y velocity. See, if true, and the agent uses 2D avoidance, it will remember the set Y and reapply it after the avoidance step. While 2D avoidance has no Y-axis and simulates on the flat plane, this setting can help to soften the most obvious clipping. Okay. I don't know if that's helpful for us. So then what I want to do over here is look at the 3D GD script. We are a character body 3D, so we want to look at the character body. Okay, I see. So we have our speed. We have our, oh, interesting. So they have navigation. So I'm just now learning that there's this notation, but there's also this notation. Which I think requires this to be encompassed with that. And then you can do that. So you can do this as well. That's cool. I like that. I mean, I like the shorthand better, obviously. Okay, so we have our navigation agent 3D. We've gotten our navigation agent. The next step that we want to do, start room. Let's go ahead and close this. This here is our test room. This here is our test room. Control. Let's save this. I want to look at the dungeon scene in my player controller. Player character 3D. Player character. You're in a bad spot. Let's take our player character and just move him right here. And then just for funsies, let's take our rat character and we're just gonna place him right here. So our rat scene which is a character body 3D. It extends character body 3D, and then this here is our script for the rat scene. GD. So we would go for our script. We would go up to the dungeon. So we're just going to say at on ready player. This is just for a strict test of our rat. We're going to say player. Our player is a player character 3D equals dot player character 3D. I don't think that is correct. Oh, that's the only place we use this here. I think I'm just going to say player character. Expected node path as string. So this here I think needs this. Yeah. This here technically doesn't. We'll add it anyways. So if I did dot player character. We'll just go with player character. And then I would say input direction. To vector 2D. I think that this is correct. Unused. 2 player. Okay, so that's the input direction. We're going to actually say 2-player. Get rid of that. And actually, no, we're not going to say 2-player. We're just going to say player POS is going to be the global transform.origin. And then, let's see here. This is interesting. Okay, on navigation agent that velocity that computed on velocity computed set movement target. I don't know what this on velocity computed. On velocity equals the safe velocity. I'm sure we'll get there in a second. Set movement target. So we're not going to add a set movement target, so we'll just do a control copy here. Player position, we'll say movement target equals to player.global. And then we will say you are in the physics process. Navigation agent that set target position. Identify navigation agent. Let's just call this navigation agent. See here. These lines look important. Get map iteration ID 0 return. It's navigation finish return. Excuse me. I'm basically just copying and pasting, but I'll go over these here in just a second. Okay, so we have a new velocity, vector 3, global position. Movement speed is actually speed. If navigation agent dot avoidance enabled, navigation agent dot set velocity equals new velocity, global position dot direction to next path position times speed. Okay. Else on velocity computed. Which is interesting. Here, let's just get rid of this here. So here we have on velocity computed, velocity equals safe velocity, which I guess we pass in, and then we say move and slide. But we also have a on velocity computed on function ready for navigation agent velocity computed dot connect callable on velocity computed navigation agent. So is that, so we go to our rat scene here. And type in velocity. I don't actually know if we highlight this, what's it say? Navigation agent 3D, see here, notifies when the collision avoidance velocity is calculated. Okay. Emitted every update as long as avoidance enabled is true, and the agent has a navigation map. Okay. So in theory, we should have a moving rat that follows the player. So if we save this, and then hit play, we either crash. Oh my! So, okay, rotation is an issue, but oh, it cheated, so there should be, I think there should be another rat around here somewhere. Okay, that one cheated. I don't know where the other rat is. Is there a... You know what I really want to do? That's not what I wanted to do. Can do like a shift F1 or shift tab or an alt tab. Whoa. Okay, so you can pause it. You know what I wish? Godot. See active scene tree. I want to see the scene tree while I am in game. See here in the scene tree while in game is running. New tab is added to the top of the tree view. Oh, so if I hit play. Oh. So if I hit play here, and I say Alt Tab, I go to remote. Here we go. This is quite annoying. Okay, so here's our rat friend. So this rat will automatically follow us, but I'm running into... Okay, now we're riding the rat. I'm running into an issue. Where's the other rat? Oh, you know what the issue is? The issue is that I added the rat to the dungeon. That's what the issue is. Delete the rat scene, hit OK, go to our test room, and choose a room area. Okay. Should probably fix the code around that if I can. But let's see here. Let's add a... Well, let's do this the right way. Let's add a rat here. We'll add a rat here. We'll add a rat here. I'll add a rat here. Control save. And now when we hit play, we run into an error. Invalid property or key. Global transform on base object of type null. So it didn't get us the player. Right. And it wouldn't get us the player because we went from the scene. Now we're actually a subnode of an object in the scene. So we would actually want to ... and then do this. And then that should get us to the player character. This is just a temporary thing here. Oh, okay, here's one rat. Here's two rat. There's three rat. Four rat. Okay, so we have 4 rats. Now, next question is... So they disappear with the previous scene. That is good. Okay, awesome. We have rats. Okay, Alt F4. Our rat speed is way too fast. Some of this stuff, I should modify this. A lot of these are constants for... I should really make these... exports. But let's see here. Rats are pretty fast, but we're going to give them maybe like a 2. See what that does for us. You know, a rat usually comes from over here. Here's a rat right here. Not a very fast guy. Okay, that's... Are these rats floating? It does kind of look like they are floating, doesn't it? It does. They are. Okay. So why does the rat float? Well, I can tell you why right now. So we set velocity here, and then we overwrite velocity right here. Get gravity. So if it's not on the floor, so this here is the only place that velocity here gets set. So we have navigation agent dot set velocity. That's if avoidance is enabled. Is the navigation agent on our rat scene? Is avoidance enabled? I mean, one would think that it should be enabled. What's this do? If true, the agent is registered for an RVO avoidance callback on the navigation server 3D. One velocity is set and processing is completed. A safe velocity vector 3 is received with a signal connection to velocity computed. Avoidance processing with many registered agents has a significant performance cost and should only be enabled on agents that currently require it. Okay. So I think what it's saying... Okay, so this here is going to is called navigation agent set velocity, which will call back on velocity computed. So what this is saying is that my new velocity should probably contain a callback, not a callback, but we should just control copy. New velocity. This should be fixed. And instead of saying velocity plus equals gravity, we're going to say new velocity plus equals direction to next path. This is saying new velocity. I don't know how well this is going to work. Because we're still overriding the velocity. Right? We're saying velocity equals safe velocity. I don't want to... Thing is that if I... Because we need gravity to take effect here. Part of the issue... No, not part of the issue. This is fine. This is actually fine. Actually, what we had before is fine. Velocity plus equals gravity plus delta. What is not fine is saying new velocity. Yeah, here we go. Saying velocity plus equals gravity, that's fine. We don't actually want to overwrite our gravity velocity. So what we actually want is kind of two different things here. We're going to say... I think we're going to have two different reactions here. Because we're going to say if we're not on floor, then velocity plus equals... get gravity plus delta. That's going to be our velocity. else. We could uncomment this here. Well, we don't have a jump, so let's actually comment this out. So our movement, so this here is our movement target, is our player, and then our navigation agent, we're going to set the target position to be the movement target, and then we're going to say navigation server 3D. We're going, okay, we're just checking the navigation. This here's the next path position. There. New velocity. So this here's the next path position. And then new velocity times speed. This here is the direction to the next path. I don't think we want the else. We want to keep velocity. We have the safe velocity, but we want to hold on to Y. New velocity. It's going to be towards new velocity. We haven't updated the actual velocity yet, so we can actually say control copy. We can say new velocity dot y equals velocity dot y. Probably, I don't know. Let's give it a shot. See what happens. Should have a rat coming from this way, or it'll fall through the floor, one or the other. But it should be on the floor, which it now looks like it. Yeah, I could actually step up on it. It is on the floor, so that is good. Oh, here's this little rat guy. It looks like there are some navigation issues. I mean, if I come up here, they are trying to go through the floor. Trying to figure out what these guys are trying to do. Is there a way? See here, view environment, view information, view frame. I want to how am I singing use local space view? View settings? No. Project. How am I seeing? Shit. Debug. Oh, here we go. Visible pass, visible navigation, visible avoidance. Okay, so there's obviously no path there. If I come up here, this guy is actually... They seem to be completely ignoring the path. Because if I drop off here, they're just going to jump. No, they didn't jump. I wonder if they're having issues because they're not colliding with the... collision. So for instance, if I come over here, did they just run into the wall? They didn't make it up here. Come on, you little guys. Okay, I do see there are some potential issues, but if I come over here... Okay, so they all made it over here. And then say come over here. Do they still come around the wall? They do. So they're not hopelessly lost. If I come and jump down over here... Oh, they're stuck on the lip there. You guys get stuck on all the lips. Doesn't look like there's much of a lip here. They get stuck on that lip. Okay, so they were able to come over the edge there. So they make it down. Oh, interesting. So there is an issue. Okay. If I reset this and then hit play, how do they behave? So this is probably something that is potentially fixable with just changing their settings a little bit. I think he's stuck. Yeah, see, they get stuck behind it. Okay. So this could also be an issue with that's the navigation agent. If we go to our test room and set our navigation region, and our cell sizes are... Oh. Let's just say 0.5. 0.5. No. 0.25. 0.25. And clear, bake the navigation, hit play. So now we've rebuilt the navigation mesh. Okay, see, now we've gotten this problem here. Yeah, see, that's maybe 0.5. I mean, we could go change the cell size. We could go change this. Here is our max slope, our max climb. Radius, regions, edges, max air 1.3 meters, polygon 6, sample distance. Clear, bake, play. I'm still seeing weird stuff with the navigation here. We do 1, 1. Okay, that's better. Why are you wanting to go underneath here? Let's see here. We have our collision shape here, which is the size of the rat. Maybe we bring this up to what? Maybe 0.5? I mean, that's massive. 0.2, see what happens there. I mean, maybe that changes things. I'm not entirely sure. Okay, that's better. It still gets stuck. And I think it's because this needs to be, if we look at our test room, 0.1 is our height and radius that we're saying for the agent. So if we go to our rat scene, and what was that? 1. Just out of curiosity. Now our rats have a huge collision box. Way big. Okay, I see. Point 1. So it's almost like the rats need their own collision. Okay. So if we go to our test room and we set the cell size to 0.1, the cell height to 0.1, the border size, what's this do? Size of the non-navigational border around the baked boundary area in conjunction with filter baking. Blah. Entirely sure. Height 0.1. Radius is 0.1. Here, see here, max climb. The minimum ledge that is considered to still be traversable. Oh, okay, I see. The maximum slope that is considered walkable in degrees. Okay. So if we do that, we do come up to an issue. If I clear navigation, then I bake navigation, we get some errors down here. But if we go to project settings, and we go to navigation, go to 3D navigation, set this here to 0.1. 0.1 is going to be the minimum size on these. And then the default edge connection should be 0.1, I believe. Then hit close, clear navigation, bake navigation. See here, navigation region. More than 2 edges tried to occupy the same map rasterization space. So I think we go to project settings and merge rasterizer cell scale 0.1, close, clear, bake. More than 2 edges. So there's a project settings. This is probably not this here. And this here is default edge connection margin 0.25. These are 0.25, 0.1, 0.1, 0.1. I guess the other option is I could make my rats bigger. I mean, they are pretty small. Default link connection radius. Default cell height, cell size. We could keep that and clear and bake. Navigation region synchronization error. More than 2 edges tried to occupy the same space. I mean, I guess my question is how much of that matters? I don't know where the error is, if that's something that needs to be worried about. I don't see any particular issues that might cause. Navigation region synchronization error. More than 2 edges tried to occupy the same map rasterization space. This is a logical error in the navigation mesh caused by overlap or too densely placed edges. So the edges are too dense. So we go into project settings. I mean, can we do like 0.15, 0.15, and if enabled, 3D navigation regions will use edge connections to connect with other navigation regions within proximity of the edge navigation map. The connection margin. This setting only affects world 3D default navigation maps. Okay. Still get the same issue, but if I hit play, I mean, how much does that affect us? Oh, a lot, because this isn't our navigation mesh. So it's basically saying, if I'm not mistaken, if I look at this, yeah. So it's not using this map. It's using the previous map. If we go and look in here. Oh no, this is... Okay, now it's using the right map. We just had to save, I believe. I think this here is kind of the error it was talking about. But if I come up over here... Yeah, these things still get lost. So it's not a lot of help. Or so one of the main issues is actually these ramps. Let's go to our navigation region here, and let's just see here. 0.25 is fine. Let's do 0.25. 0.25. Clear, bake. Okay, everything's fine. Save. This is still a problem. Why are you doing that? Well, we might be able to fix that if we go into our test room scene. And let's actually take our wall 1, wall 2, our ramps. And well, let's thicken these out a little bit, shall we? So instead of saying 0.1, let's say 0.25 for our thickness. And our position. Let's just plop this down here. So this is within the scene. And then let's take our position. We will copy that. And then we'll go with a 0.25 here. And then we'll take our position and we will paste our value here. So let's do that for ramp 1. Let's go with ramp 2. The mesh. Oh, it's using, I think it's using the same mesh for all of them. Okay, that's actually good. So the only thing that we actually need to change then is the position of the mesh. And then the collision shape, it's not using the same collision shape, is it? It is using the same collision shape, it's just the position that needs to be applied to each collision shape. And then the idea behind this is we will clear the navigation, bake the navigation, save. We still got some wonky frickin' navigation. Yeah, see, what is this all about? I don't know if that's going to fix anything. Trying to figure out this navigation system's just kind of a little bit wonky. Like, I would like it if these guys here could just come up here, but they won't. And I don't know why that is. Is that the cell height? Or is that the height and radius? Well, this here is the agent. This here is the cells. So here I've created some much larger cells, which now the navigation's at the player camera height. Oh, now these guys, they won't even attempt to move. Okay. So it is strictly 0.25. 0.25. That's asking the 0.25 on that is fine. We can't go less than 2.5 or else we get some wonky stuff. This here, well, if I do this here and hit save, let's just do 1 and 1 for the agent and not change the cell. So is this still, yeah, the agent is still not moving. The agent doesn't understand. So if I do 0.25, 0.25, okay, now the agent knows that it can move. The agent still can't figure out how to navigate these damn ramps, so maybe we need to redo our ramps. Do this here. Let's clear the navigation, get it out of my way. So here is our mesh instance. Let's do something different here for our mesh instance. Let's go ahead and get rid of that. Let's reset. And let's reset that. So mesh instance. Let's get rid of this and this. For ramp 1, let's actually remove ramp 01 completely. Delete. And let's go ahead and add a CSG. Let's do a CSG. Combiner. Create. And then add a CSG. Polygon? Okay, this here is the CSG polygon. Okay, this can work. Ahead and bring this down to, I don't know, 18 by 18. Let's take our view. Let's do one viewport, and then let's do the perspective. And I want to remove, I don't know which polygon. Oh, okay, I see. Local space. Zero. Let's remove 1 1. There we go. Okay, now that 1 1 is removed, we could say depth of, I don't know, 4 meters. What is depth? Spin. Path. Okay. Yeah. Be nice to offset. You know what? I know there's a way to edit polygon. What did we... CSG polygon. Aha, here we go. Okay, so let's add a transformation of, I don't know, 45. Negative 45. And let's just move it this way a touch. Maybe here. This is hard to tell what is where here. Okay. And let's just take this polygon, just move it down just a touch, just so it's maybe right there. It's in the floor a little bit. Make sure that this one is in the floor a little bit. Okay, and then as far as materials go, I'm going to go ahead and throw on our default grid material if it'll let me. Yeah, we'll just do that there. And then collision. There's geometry. Calculate tangents. Operate union. Flip faces. Material smooth faces, positions, physics, auto translate. I think it's going to be the CSG combiner, actually. Use collision. There we go. Okay, so now that we have this, I think we can take this polygon and then duplicate it a couple more. Well, before we do that, let's take these two and delete. Okay, and then this one here, we want to rename to ramp_01. And then duplicate this a couple times. And then we want to go into the transform. We're going to say negative 17, rotate 90 for a positive 45. And then this one here, we're going to transform to be negative 17. And then we're going to rotate this 180 to be a... I don't actually know. 45 is 90, plus 45 is 135. I hope. And then ramp 4 transform is negative 17. And then we rotate you to be negative 135. Control save. Now, I could move these ramps to be a little bit more centered, but I'm not going to. Now I'm going to do navigation. I'm going to clear the navigation. I'm going to bake the navigation. And of course, the navigation still broke as shit. And that is probably because our... Is this going to be our voxel size? Our cell size? Well, no, our navigation... Our cell size? Dang. 0.5 tab 0.5. Okay, this here is hopefully a little bit better navigation. Boy, this is annoying trying to figure this out. Okay, here comes our little rat friend. Let's lead him over here. So if we now come up over here... You're an idiot. I think the reason is because they're trying to cut corners that they normally would be able to cut. So the issue isn't the ramp. There must be some fine-tuning to the navigation. Cell size 0.25. So is the issue with the rat scene, is it because the collision shape... Well, this here's the navigation agent. Path... Okay, well, let's adjust the navigation. See here, path height offset. See here, the height offset is subtracted from the y-axis value of any vector path position for this. The navigation agent height is offset does not change or influence the navigation mesh or pathfinding query result. Just navigation maps that use regions with navigating meshes backed with the appropriate agent ranges or height values are required to support different size agents. Okay. Okay, so they have this here, and then the path max distance. Hey, where are we going, desk? Oh, avoidance. Oh, this here is if avoidance is enabled. We don't have avoidance enabled, so path height offset. The height offset is subtracted from the y-axis value of any vector path position for this navigation agent. The navigation agent height offset does not change or influence the navigation mesh or path finding query result. Additional navigation maps that use regions with navigation mesh baked with appropriate agent radius or height values are required to support the different size agents. Okay. Max distance, target desired distance. So if our rat has a collision shape that is a radius of 1 meter, let's say 0.05 meters, then we could say that the navigation path height offset 1. I don't know. Still seems to be getting stuck. Yeah, see, I think it's path max distance. The maximum distance the agent is allowed away from the ideal path to the final position. This can happen due to trying to avoid. Let's do 0.1. I think that's where we're getting stuck. They're pathing. Oh, you know what? Their paths are probably. Oh, that's probably what's happening. You know what? I know what the problem is. Target desired distance. Distance threshold before the target is considered to be reached. Path desired distance. The distance threshold before a path point is considered to be reached. Path max distance. If true, a simplified version of the path will be returned with less critical path points removed. I want to see we don't have avoidance, visible paths. Okay, these don't actually become okay. What's happening is that the path, if we go to your test room here, I think what's happening is the path is jumping from here to here instead of going around. So that might be, I don't think that would be necessarily a navigation issue because these here are polygons, filters, resources. I think that's going to be the navigation agent on the rat Let's say path desired. So here's the target desired distance. Here's the path desired distance. The distance threshold before a path point is considered to be reached. Okay, that's the target reached. The max path distance, the maximum distance the agent is allowed away from the ideal path. The issue is that our A star path C path post processing. Star. We hit none on this. You see how he just dropped over the edge there? I know what the issue is, I just don't know how to fix it. Path search max polygons. Path desired distance. I just want this damn mouse to follow this path, man. Path search max distance. It's not here. Does this seem like not going to turn on? I gotta use the restroom. I'll be right back. Sorry, I'm back. Out of curiosity, Okay, so it's still wonky. They still do cut corners, but at least they make it. So there is kind of an issue. I see what needs to happen here. So our test room navigation, the cell size, the cell height is 0.25. We're saying that the agent height is 5 meters. We know that this guy is 0.05, so the offset needs to be 0.495, I believe. So if we go to our rat, or forward 5 for the offset, because our collision shape is 0.05, so 0.45. Save. And now if we hit play, he's where he's supposed to be. If we come up over here, does he pathfind? He does pathfind. Well, not really. I think the issue is that it's just such a small type thing. If I take, out of curiosity, if I take the body mesh and I say transform and I say scale, it does scale everything. So maybe we just make him 2 times as big. We take our collision shape, .15. Then we go to our navigation agent. So we added 0.1 to this, so 0.35. It's probably more of a rat size anyways. He still gets stuck, which is fucking frustrating. I go to my test room, go to the navigation region. .15. 0.15. I still get this weird. Which I'm unsure about. Well, that's not it for one. So we have to save this and then hit play. Okay, here we go. So our navigation's a little bit wonky. We got some weird stuff going on, but nothing is fixed. Okay. We'll pull a fast one. What you talking about, my dear? Hmm. This is not working the way that I expected it to. Am I on the wrong? What the heck? Does this really not show? I am shooting it now, right? And we've only dropped to 1.6%? What? Mm-hmm. Something is not right here. And I'm not entirely sure what to do about it. These sit where they're supposed to. Okay, here's a question. If this is this, if I go to my agent on the rat and I remove this offset, save, hit play, what does actually happen with this weird broken mesh? Obviously the rat made it down here in some fashion. Here he comes up. Okay, he gets very, very stuck. So, okay, so let's go back to... Well, maybe there's a way we can fix our navigation mesh, because we're just dealing with cell size, agent height, and things along those lines. What if is there a way? See here, regions, min size, the minimum size of a region for it to be created. Merge size. Any regions with a size smaller than this will be merged with the larger regions if possible. Edges. Max air 1.3. The maximum distance to simplified contours where edges should be deviated. Should deviate the original raw contour. Let's change this to maybe 0.5. Oh my. How about 1? 1 doesn't seem to do it. How about 0.7? 0.7 we get, it looks like we get something that's a little bit cleaner, but I really do think that we're still going to run into some issues. Polygons. Vertices per polygon, 6. I don't know what it's calling a polygon. Details. Sample distance. Air filters. Excellent. The maximum allowed length for contour edges along a border of a mesh. Value of 00 disables this feature. What if we do this here and we say, maybe just say 1? Okay, I see. So that's the border. Okay. I'm trying to figure out how best to clean up this navigation to make it do what I want it to do. This is just bullshit. And I think part of that has to do with my cell size. Maybe if I go to like a 0.15 for the cell size. What's the difference between cell size and cell height? The cell size used to rasterize. Oh, to rasterize the navigation mesh vertices on the XY plane must match with the cell size on the navigation map. Border size. The size of the non-navigable border around the bake bounding area. In conjunction with the filter baking and edge max air value or below, border size can be used to bake tile line navigation meshes without the tile edges being shrunk. Okay, I don't know if that's any useful. Clear that, run this here. Oh, interesting. We didn't get an error regarding that. We know that our guys are 1-5. See, this here is going to cause them to miss this. Here's our rat friend right there. Let's go ahead and hit play. Why do we have whatever? Okay. You are obviously offset incorrectly. Where did... Okay. Oh shit, that fell. That is fine. Merge size, min size. So it looks like there is some extra refining that can be done, but I think I can go into my rat scene, into my navigation mesh, turn this offset off. Okay, it is off. Let's bring back our gravity navigation. Hit save, and now hit play. So this just applies gravity back to these guys. So now they're operating off of gravity instead of sitting at the height of the navigation mesh. They still break. There's also a navigation mesh inside of this, which is problematic. Why? Yeah, why would I do that? I think I saw, yeah, you can't see it from out here. They put navigation inside of these as well. I'm not sure why it would do that. It's basically saying, hey, you go ahead and hop inside of these walls here. That shouldn't... It shouldn't be doing this. I feel like I just need to learn all about navigation now. I mean, okay, yeah, let's not. Huh. Really... Well, if we go to our navigation region, so this here is our cell size. This here is the size of our agent. So our cell size, we could actually revert this to 2525. And one would think that in theory, that would give us a decent mesh to work off of. The issue, and this is the issue that we're getting, is that it's putting meshes inside of places where there shouldn't be meshes. So even if we reset this, which we could fix here in a moment, there is still, yes, okay, yes, there are still meshes, okay. That's what needs to be addressed. So 0.15, 0.15. Navigation mesh inside of static collision. This here is an Unreal Engine. Good go. Let's see what ChatGPT has to say here. Navigation meshes do not automatically conform to static project 3D collision navigation. This is driven strictly from geometry sources, not physics shapes. Okay, blah blah blah. Key principle critical navigation static collision. I know it doesn't, bud. Enable geometry parsing. Bake. Or navigation mesh settings. Root node. Source geometry mode. Root node children. Parse geometry type meshes. Where do you see? Mesh? Oh, this is all information about the navigation mesh. Okay. Resources, filters, low-hanging obstacles. Oh. If true, marks non-walkable spans as walkable if their maximum is within max. Okay. Ledge spans. If true, mark spans that are ledges as non-walkable. Low height spans, bounding box, bacon cost, resources, filters, details, sample distance, and air, polygons, vertices per polygons. Someone help me out here. Geometry. Navigation region 3D. Navigation region 3D. Oh, geometry. Parse geometry. Static colliders. Mesh instances. Static colliders. Both. Collision can be more complex or simplified independently. 2. Invisible navigation only. Use collision shapes, not directly walk arounds. Wait a second. Are you saying that if I take my CSG combiner and I turn off collision and then I hit save and then I select my navigation region, I clear the mesh and do this? Oh, it's completely based off of the mesh and it's not even based off of... Oh, that is a problem. Yeah, that is a problem. Why wouldn't you... could procedurally generate a nav mesh. Oh man, why would you... do that? I'm kind of interested in... So if I hide these and then I select the navigation region, save it by the way, and then clear navigation and then bake navigation, no, they are still hidden. Actually, static colliders. Oh, because it's doing it both. It's doing it based off of mesh instances and static colliders, when I think we just want to do static colliders. There we go. There we go. And then bring this back, use collision, come back, save it, come back to the navigation, clear, bake. We can go ahead and visualize this. Now we don't have any... Son of a bitch. I think my issue here with the ramp it could be one of a CSG nature. So if we just remove this and clear this and add, in this case, let's just add a static body. On the static body, let's add a mesh instance and a collision shape. The mesh instance is obviously going to be a well, that's interesting because we had, well, I know what we had before. So our issue is, I think that it's jumping. Well, I know what the issue is how do we resolve it? Code. Be there in a minute. I gotta go put some wood in the fireplace for the pretty lady. How do they not just have like a... They have a quad mesh, a prism mesh. How do they not just have like a rectangle mesh? You know what? A lot of this stuff doesn't even matter. I mean, I've got collision figured out. Not collision. I got navigation. Kind of figured out. Let me go ahead and save this. I'll be back in a minute. Ooh, the back. Oh, what? Did music stop? All right, guys, I'm back. So I think we're actually going to wrap this up here. I got some things to go do. Um, got navigation mostly figured out. I do want to watch some advanced videos, kind of dig into it a little bit deeper. I am out of breath. My good God. Do want to dig into it a little bit deeper here later, but for now, I think we're gonna leave it off where we are, and hopefully when we come back, I'll be a little bit more knowledgeable. I do have some ideas. Probably gonna need to start working on building a state machine. I could use Limbo AI, but I do kind of want to learn how to do it myself, so probably gonna go that route. Or at least figure something out myself. Anyways, thanks everyone for watching. We'll see y'all next time. Peace out.